So far, we've seen the definition of a derivative, what exactly is a derivative, and also the limit definition of a derivative, as you can see here. But using this limit definition of a derivative to find the derivative of some function every single time is pretty slow. Luckily, there are different rules, different differentiation rules that you can use to make differentiating these different functions much easier. All right. The first one I want to show to you is the power rule. Right. Let's just button this. If f of x is equal to x to the nth power, then f prime of x, or the derivative of f of x, is equal to n times x to the n minus 1 power, where n is a real number. It's a pretty simple rule, right? So if you have the function, I don't know, x squared, the derivative of the function is going to be 2x, right? If we have, let's say, x cubed, it will become 3x squared, and so on and so forth. If we have a polynomial to a negative exponent, let's say negative 2 or 1 over x squared, right? You can get the derivative by doing the same power rule, bringing this 2 down, this negative 2, and subtracting 1. So this would become negative 3. So this would turn into negative 2x to the power of negative 3, which is also negative 2 over x cubed. I'll show the derivation or the proof behind the power rule in another video, but I just wanted to introduce this concept to you right now. But before I end off this section, I want to share one more example. We have the 7th root of x to the 11th power. Right, you can simplify this to x to the 11th over 7, taking the derivative of this. Let's say this is equal to y. Dy dx is going to be 11 over 7 times x to the 11 over 7 minus 7 over 7, or minus 1 rather. This 11 over 7 is hopping down here. It's being subtracted by 1. So this is equal to 11 x to the 4 over 7, right? All of that over 7. We also have something called the constant multiple rule, right? All this is really saying is that if you take the derivative of some constant times some function, right, it's the same thing as this constant times the derivative of this function, right, f of x, which is also the same thing as c times f prime of x. Let's show an example here. Let's do f of x is equal to 7x to the 4th. If we were to take the derivative of this, it would just be, well, I'm going to do that by doing this. F prime of x would just be 28x cubed, right? Because this is being brought down. 7 times 4 is 28. And 4 minus 1 is going to give us 3, right? But you could also see this as 7 times x to the 4th. And this, in turn, would be 7 times 4x cubed, which could also be 28x cubed. Either way. We also have something called the sum or difference rule, right? All this is really saying is if you take the derivative of two functions, f of x, I don't know, let's say g of x, sum together, it's going to be the same thing as f prime of x plus g prime of x. You can consider this derivative operator as like a distributive property onto this. You could visualize it like that. Let's try an example. I'm going to use different notations to try and get you used to it. So x cubed plus 5x squared minus 7x plus 4, right? If you're taking the derivative of this with respect to x, dy dx, you will get 3x squared, right? This 3 is hopping down. You're subtracting 1, so 3 minus 1 is going to give us 2. 10x, right? This 2 is hopping down, multiplying with the 5 to give us 10, right? And 2 minus 1 is going to be 1. X to the power of 1 is, you could also just write that as x. I'm going to write this here, right? So minus 7x x to the power of 1 multiply negative 7 by 1, you're going to get negative 7. If you subtract 1 to the power, you're going to get x to the 0th power, which is also just 1. So it ends up just being the constant right here, right? And then plus 4. Well, you don't really need a rule for this, but if you have a function that's just y is equal to 4 the entire time, the derivative does not change with respect to x, right? So this term just ends up disappearing altogether, right? So this is our final answer for the derivative of this function, or this equation here.